Okay, so now we write that same old square root program, but why again? What has it got to do with the floating point numbers that we are learning over here? See, square root of a number, if I want to find out, if you remember last time, when the input was 49, we outputted 7 because 7 is the square root of 49. But when the input was say 43, then we said the exact square root is not possible. The exact square root is not possible. And the idea is that nothing is actually the exact square root of 43. You can say 7 into 7 is 49, or say 6 into 6 is 36. But the exact square root of 43 is not possible because nothing into itself is 43. But one thing we can be sure of, that yes, 6 into 6 is 36. You check out what I want to say. 6 into 6 is 36. Now, 7 into 7 is 49. If somebody asks me what is the square root of 43, you can so easily guess that the square root of 43 is somewhere between 6 and 7. Square root of 43 is between 6 and 7. It is, that means it is 6 point something, which is the square root of 43. So it is a floating point number. The square root of 43 is a floating point number. Now, how to find out the square root of a number which may be floating point? If it is 49, my program, if the input is 49, should print 7. If the input is 36, it should print 6. But if the input is 43, it should print 6 point something, which is the square root of 43. Question is, how to calculate the square root of 43 or something like that, which is a floating point number? Check out how. For that, you remember the logic that I used. The logic that I used was, I started by calculating 1 into 1, which turns out 1. Then I calculated 2 into 2, which turns out maybe 4. Then 3 into 3, which turns out 9. And so on, we kept on checking until and unless I reach say 49. If I am given to find the square root of 49, in this way, to find the square root of 49, I start from 1 and then calculate 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. In this way, sometimes or the other, I reach 6 into 6, 36. And then, when I calculated 7 into 7, 49, I immediately understood that the square root of 43 is not exactly possible, because prior to this 6 into 6 was 36, which was lesser than 43. So I continued, but 7 into 7 is 49, which is more than 43. So the square root of 43 is not possible in this case if it is 43 then. However, if it is 49, then once I find 7 into 7 is 49, I immediately said that the square root of 49 is 7. So now let us try to find out the square root of a number which may be floating point. For that, the same old program of finding the square root in case of which the exact square root is possible. How I wrote that program? You remember, I wrote it like this, that for, I used a while though at that time maybe, but if I use a for loop, then I can start with I equal to 1. Now what is this I? Remember, this I is 1. Next I will increment I and I will get I is 2. Next time I will increment I and I will get I is 3. Next time I will increment I and I will get I is 4. Next time I will increment I and get I equal to 5, and so on. I will keep on continuing like this. So now I can say that I will be 1 from which I start, and every time I will calculate I into I and check whether it reaches the value n or not. So for that, for I equal to 1, then whatever I will check later, but here I should check if I into I is greater than or equal to n. You immediately understand that you have either reached, say this n is 49, you want to find the square root of 49. So once you find that I into I is equal to n, you know that you have reached the square root. Or maybe if this n was 43, once this I has reached 7, 7 into 7 is 49, this 49 has squared, has exceeded the 43, you immediately understand that the exact square root is not possible. I explain once more. N is 49. So I start with I equal to 1. 1 into 1 is less than n. So this loop should continue. Then I is 2. 2 into 2, 4 is less than 49. So I continue. Next I is 3. 3 into 3, 9 is less than 49. I should continue. In this way, when I reach 6 into 6, 36, still it is lesser than 49. I should continue. But once I is 7, 7 into 7 is 49. I should immediately break out of the loop, thinking, understanding that I have reached I equal to exactly the square root value. If this I was 43, in that case also 6 into 6, 36 is lesser than 43, I should continue. But once 7 into 7, 49 is greater than 43, I should immediately break out of the loop. I should go out of the loop, thinking that I have reached a point where I have understood that a square root of 43 or the square root of n in this case is not exactly possible. So if I into I is greater than equal to n, I should break out, thinking that either I have reached the square root or I have understood that the square root, exact square root is not possible. So over here you remember an I plus plus is needed at the end. But between this, what should be the condition checking? See, the condition checking I have done over here. If I into I is greater than equal to n, I break out. Otherwise, no condition is needed. I will start from 1. I will check whether 1 into 1 is lesser than 49. If it is, I continue with I plus plus, I is 2. Condition checking is not needed, but because once this I into I is either greater than or equal to, I will break out of the for loop. So this part of condition checking should contain nothing. So for I equal to 1, or no condition check, I plus plus, if I into I is greater than equal to n, I break out. Now once I break out, I come over here. I come out of the for loop. Now coming out of the for loop, there can be two conditions. That is, I into I can be equal to n. If it is equal to n, then I know I have got the exact square root. Say n is 49. In that case, 7 into 7 will be exactly equal to 49. I will understand that I have got the exact square root. However, if n is 43, then 7 into 7 will be 49 will be greater than 43 and I will come out. 6 into 6 is 36, I will continue. But 7 into 7, 49 will be greater than 43 and I will still come out. So I into I equal to n means I have got the exact square root. So coming out over here, I can check if I into I is equal to n, I can immediately printf, the square root is, what is the square root? The square root is I itself, because I into I is equal to n. So once I into I is equal to n, I can come out of the loop and say the square root is I. But if I into I is greater than n, say n is 43, 7 into 7 greater than 43, I can still break out. But over here I into I is not equal to n. Then else part what? Here I understand that the square root is not exactly possible. So remember in my last program when I tried to find out the square root without using floating point number, what did I do over here? I printed that the exact square root is not possible. But over here I will not do that. I will print, I will try to find out the exact square root, which is 6 point something. So what can be the logic? The logic is, suppose 43 is the number whose square root is needed. What I will do is, I have come over here with a value of I is 7 because n is 43. 6 into 6 is lesser than 43. I will continue. I is 7 next time. 7 into 7, 49 is greater than 43. I break out. So once I have been given 43, I know I have reached over here with the value of I equal to 7. What I will do is, I will take a value just less than I. That is, I will start from 6 because I know that the number should be 6 point something. Now, if I want that 6 point something to be up to 2 places of decimals, so I can do something like that. I check with 6.01. That is, I will check 6.01 into 6.01. Is it equal to 43 or it is greater than 43? No, I will continue. I will continue and make it 6.02. I will increase it 0.01. 6.02, and again I will check 6.02 into 6.02. Is it greater than n? If it is greater than or equal to n, I come out. I know I have got the square root. But if it is lesser than n, I will keep on continuing and I will go for 6.03. In this way, sometime or the other, I will come to some 6.xx, where I understand that over here, this 6.xx into 6.xx is greater than n, greater than 43, and I know that I have got the exact square root, either greater or equal. Either greater, equal means I have got the exact square root. Greater means it is just the square root nearest to that, you remember. Suppose 6.03 into 6.03 is lesser than n. But 6.04 into 6.04 is greater than n. I immediately understand that the 6.04 is the nearest square root of that n right now. So I think you understand what I mean to say. What I mean to say is I will keep on increasing 0.01, 0.01, 0.01 in this way. So suppose I have reached 6.03. 6.03 into 6.03 is lesser than n. I know I can still continue. But 6.04 into 6.04 is lesser than n. I can still continue. But 6.05 into 6.05 is just equal to n. So 6.05 is the square root. 6.05 into 6.05 is greater than n. I will not continue. I will say that I have got a square root which is just almost the square root of 43, the nearest square root of 43, up to 2 places of decimal. So this is the program I want to write. So here the logic should be like this. For j should start from I minus 1, but remember j is a floating point number. If I has come out with 7, number was 43, I will come out with 7, I have to start from 6, but not 6, I will have to start from 6.00. So remember j is I minus 1, okay, but not exactly I minus 1, it is float I minus 1, that is 6 being converted to 6.00. Condition checking will not be required because once it is greater, I will break out like this. The same logic I will use. Instead of plus plus, I will increment it by 0.01. Otherwise, logic is absolutely same. Once I get it is greater than n, I will break out. So for j equal to float of I minus 1, no condition checking is required, but j has to be incremented by 0.01. I think you understand. J will have to be incremented 6.00 to 6.01, 6.01 to 6.02. In this way, I will keep on incrementing j and check whether j into j is greater than equal to n, not n. N is an integer, float n. Change that integer to float for the comparison because you are comparing a floating point. J is a floating point number. J into j is another floating point number. You are comparing it with float n. Remember, j has to be declared as a floating point number because j is 6.00, 6.01, 6.02, 6.03 like that. First time we are using the iterating variable as a float. We have never done this. We have never done it like this. We have always done 6, 7, 8, 9 like this. But over here, 6.00, 6.01, 6.02 and so on. So I am checking with a floating point number. J is a floating point number. The incrementing number is a floating point number. So if j into j is greater than equal to float n, you immediately understand you have got the nearest square root. If it is equal, exact square root. If it is greater, nearest square root. You break. In any case, j will be your square root, exact square root. So if j into j is greater than equal to float n, you break out, but you break out of the for loop. But you remember that once you break out of this for loop, in this else part, you will have to write the exact square root over here, the floating point square root over here. So what should you write? Printf, the square root is percent, not percent d, it's percent f. What is that percent f now? It is j. It is j. J is just the number greater than the square root of n, or exactly the square root of n, or maybe point up to 0.01 greater than the square root. So the logic is up to 0.01, but remember over here it is better to write 0.2f because you have done up to 2 places of decimals. So because you have done up to 2 places of decimals, it is better to write 0.2f. So you print the square root exactly like this. You remember this else bracket will have to be closed. Another thing you must have seen over here, this for also I have not given a bracket. Do I need a bracket? Because over here there are two lines. So do I need a bracket? If does not need a bracket because there is only one break. This if also does not need a bracket because there is only one break line over here, one line within this. But does this for need a bracket because there are two lines? Answer is, till now I have given brackets, but this bracket is also not needed because within the for I have kept this only if. Now this only if, you remember, cannot be, this only if cannot be a single line. This whole if is absolutely one thing, one unit. So this one unit means that this for contains only this one unit. Had there been another line over here, for would have needed a bracket. Like this for also, it does not need a bracket because there is only one unit of if. But this else needs a bracket because you have written this for unit, entire for thing, and another printf. So this else needs a bracket. Two lines are there. So this printf is clear. You have printed j. Now you complete the declaration parts very quickly. You know you need an int n, and that n has to be inputted from the user. I have not done that. You need an int I. This I is needed. This n is needed. Similarly, you need a float j. This j is the only floating point number that you need. No other numbers are there needed. So you need also a float j. So int n comma I and float j. So another thing I need is to input the n, printf, enter the number whose square root you want to find. So this thing, and you need to scan it where? Within n. So scanf %d ampersand n. So this much of the program should solve your purpose. So this is the whole thing that I wanted to point out. If you find the exact square root over here, I into I will be equal to n, then you print the exact square root. But if I into I is greater than n, then you come to this else part, because you have broken out of the loop means it is either greater or less or equal to. So else part means it is greater than n, so exact square root was not possible. So up to 2 places of decimal, how to find out? By taking a j and then incrementing it by 0.01 and so on. I keep on continuing till it is greater or equal to that float n. So let us run this program. Alt R, enter the square root whose one to find. 49 should say 7. No problems. And remember, over here you do not come to this else part also. You are present only up to here. Up to here you are present. You have not come to the else part. But if you run it with 43, then see 6.56. You check out with 6.56. I am making a very quick calculation using my mobile phone to find out what is 6.56 into 6.56. I use a calculator and try to find out. See, 6.56 into 6.56 is 43.03. It is almost the square root of 43, 6.56. So I think you understand. You can be more accurate. Say you would not have done 0.01, but up to 3 places of decimal, you just increment it by 0.001. In this case, it will go by 6.000, then 6.001, then 6.002. In this way, up to 3 places of decimal you are checking. In that case, you print it also as 0.3f. Let me run it again. See, it will be more accurate. 43, 6.558. So it is more accurate. You can take a piece of paper and you can take a calculator and very quickly calculate that the nearest square root of 43 is 6.558. So this way the program can be written. I hope you understand. You have understood. We have written many floating point numbers. So we can take a bit of break over here and come back after in the next program, maybe with something new. Thank you so much.